Hi learners, welcome back to our lesson of today. We are still solving problems in pressure. In the last lesson, we calculated maximum and minimum pressure that it can be exerted by a given object, and I had given you some assignment that you are supposed to try while at home. Let me hope you have tried. I'm going to work them out so that you can check whether you have done it correctly. Here are the questions that I had given you. Question 1, a block of wood measures 3 meters by 6 meters by 2 meters and mass 3 kilograms. Calculate maximum pressure, Roman 2 minimum pressure. So solution, that is Roman 1. Now, I said that you must list what you have been given. We have the dimension and mass. We have the dimension given by 3 meters by 6 meters by 2 meters. Then you have mass, which is 3 kilograms. Now, for Roman 1, we are being asked to determine the maximum pressure. Maximum pressure. In our previous lesson, we had said that maximum pressure, this one is just equals to the force over the minimum area. This is P max. Then this one is force over A minimum. From what we have been given, we have the dimension and mass. Now, the formula is we are supposed to have force and minimum area, but we don't have that force. But this mass is going to enable us to get this force. From our previous lesson, we said that we have working force is given by mg, which equals to 3 times 10, 30 newtons. Then area, we use the dimensions that we have been given. So we have areas. We have 3 times 6, which is equals to 18 meters squared. We have 3 by 2, which gives me 6 meters squared. Then we have 6 by 2, which is equals to 12 meters squared. From these three areas, we can tell which one is maximum and which one is minimum. For this case, 18 is maximum, and this one we can denote it as X A max. And 6 is the minimum one. So this one is A minimum. So from this working, we have our force, then we have our A minimum or minimum area. So we just come and substitute it back in our formula here. And our formula, we are supposed to have force. Our force is 30 Newton. Then we have our A minimum, which is 6 meters squared. This one, when I divide it, I have 5 Newton per meter squared. This is the maximum pressure that block of wood it can exert on the surface. Then after that, Roman 2, we are being asked to determine the minimum pressure. Roman 2, minimum pressure. This is given by force over maximum area. This is P minimum, denoted by that. This is just force over A maximum. From our working here, we have our force, which is constant. Then we have our air maximum, the maximum area, which is 18. We are just going to use this 18. So when we substitute it back, we have that is 30 divided by 18. This is Newton, this is meters squared. So when I simplify, you can use our calculator. That is 30 divided by 18. It is giving me 1.667 Newton per meter squared. This is the minimum pressure that can be exerted by that block of wood on a given surface. Now, this is the working for the first question. We are going to work out now the second question. Question 2. A block of copper of density 8.9 grams per cubic centimeter measures 5 centimeters by 3 centimeters by 2 centimeters. Given that the force of gravity is 10 Newton per kilogram, determine the maximum pressure. So first of all, you list what you have been given. We have the density of the block. We have density, which is 8.9 grams per centimeter cubed. Then we have the dimension. That is 5 centimeters by 3 centimeters by 2 centimeters. Then we have our G, which is 10 Newton per kilogram. So Roman 1, that is A, not Roman 1, sorry. A, maximum pressure. Still P max is given by force over minimum area. Force over air minimum. Now, from the parameters that we have been given, we don't have force, we have density, we have dimension, then we have G. We can calculate mass. So this density is going to assist us to get this force. But first of all, we shall calculate. I have the density, the volume, I can get the mass of the block. So the mass of the block, solution. So here, if I want to get the mass of the block so that I can get the force, then this one is equals to, from measurements 1, that is from one work, we say that density, this one is mass over volume. So meaning that if I want to get mass, density, we have the density which is equals to mass over volume. Then if I want to get mass, is density times volume. Density times volume. I have density, then I can calculate the volume of the block of copper, which is just 5 times 3 times 2. This is that. So the density is 8.9 grams per centimeter cubed, then times the volume, which is 15 by that is 30 centimeters cubed. So that mass, we have 8.7 times 30. It is giving me 261 grams. Now, after this, I can now calculate the force. We said that force is equals to mg. But remember, I must convert these kilograms into the SI unit. That is kilograms. This is in grams. So I have 261 over 1000, then times 10. This is 2.61 newtons. It will give me 2.61 Newton 2.61 Newton. This is force. Now I have force. I need to find the air minimum. So from these calculations, area is equals to, we may have 5 times 3, which is equals to 15 centimeters squared. We may have 5 times 2, which is equals to 10 centimeters squared. Then we have 3 times 2, which is equals to 6 centimeters squared. So now I can tell this is A max and this one is A minimum. So our formula requires to determine a minimum area, A minimum, which is 6 centimeters squared. We convert it into the SI unit. We have 1,000, that is 10,000 centimeters squared is equals to 1 meter squared. So what about 6 centimeters squared? We have 6 centimeters squared times 1 meter squared, then over 1,000. Not 1,000, sorry, 10,000. This is given 0.0006 meters square. This is a minimum. Now, from here, we have force, then we have a minimum. So we just substitute in our equation. So force is 2.61 divided by area 0.0006. 0.006. So this is 2.61 divided by 0.0006. It is giving me 4350 Newton per meter squared. That is the first part of it. So we move to the second part, the minimum pressure that it can exert. And remember, previously we said that minimum pressure P minimum is given by force over air maximum. We have here our air maximum, but it is in centimeters squared. So we convert it back to meters. So we have 15 centimeters squared equals, so this one we have 10,000 centimeters squared equals to 1 meter squared. What about 15 centimeters squared? So you have 15 times 1 over 10,000, which is equals to 0.0015 meters squared. Now from here, our working, we have our force, then we have our air max. This is our air maximum. Our air maximum. So we substitute in our equation. So this one gives us force 2.61 over area, which is 0.0015. 0.015. So we substitute 2.16 divided by 0.0015. It gives me 1440. 1440 Newton per meter squared. So this is what we are supposed to do or to work out. This is the answer for part A, and this is the answer for part B for the assignment that I had given you. So meaning that we have done 4 questions in this area, and I would like to give you some 3 questions that you can attempt when you are at home. So assignment or more questions. More questions. these are the questions that I would like you to try. The first one is a block of wood measures 2 centimeters by 3 centimeters by 4 centimeters and has a mass of 6 kilograms. Calculate its pressure when area is minimum, B, when area is maximum. Question 2. A block of iron measures 6 centimeters long, 8 centimeters wide, and 1.0 centimeters deep, and has a mass of 360 grams. Calculate its density, that is A, B, the greatest pressure it can exert on a flat surface. Then question 3. A metal cube of mass 68 kilograms exerts a pressure of 17,000 Pascal on a flat horizontal ground. Calculate A, the area in contact with the ground, B, the dimension of the cube, C, the density of the metal from which the cube is made. This is the questions that I would like you to try when you are at home. So this marks the end of our lesson today, and we shall continue from there tomorrow or the next lesson. God bless you. Bye-bye.